Hey everybody, this is going to be part 2 of a review on units 1, 2, and 3. I have a few equations and inequalities to solve, and then some oddball type problems that we have seen as well. I'm going to start with this equation here. This is going to be an exponential, and you know, this is one that may be a little foggy. It's been a while, but we want to pay attention to what we notice here. I have 1, 2, 3 terms. Oh, sorry, that's an extra plus sign. That shouldn't be there. I have 1, 2, 3 terms, and what I need to do is try to solve. There's some hints in here. The fact that this is set equal to 0 could definitely be one of them. But the way we're going to solve this is through factoring. Now, what I hope you notice is this is something we've seen in not just this specific chapter, but this is kind of a quadratic-ish looking problem, and we could solve through factoring 9 to the x in that first location. We know that if we were to distribute, we would get 9 to the x plus x, or 9 to the 2x. And now I just need to focus on my coefficients, values that add up to -4 and multiply to -3. Those are going to be -3 and -1. So now I'm going to solve this. 9 to the x equals 3 and 9 to the x equals 1. Over on the right here, we know that x must equal 0. And then how do I go from 9 to 3, specifically with an exponent? Well, I'm looking for a square root. So x is going to equal 1/2. So we can solve equations a lot of different ways. This one, best done through factoring. Let's look at another. Here I have a natural log equation, and one thing to keep in mind here is one of the major things we want to do to solve logarithmic equations is to try to get rid of those logarithms. So I'm going to write this as a single log using my properties. I know that when I subtract logarithms as separate logs, I can rewrite them as a single log and a quotient. Now, once I have a single logarithm, I can rewrite this as an exponential. And we won't get an exact value here because I'm not going to grab my calculator, but we can see that this will be 2e to the third when we multiply both sides by 2, and then we would subtract 1. And we could plug that into our calculator if we like, but what I really wanted to refresh your memory on is that we can, when we solve logarithmic equations, we want to use exponentials, they're inverses. And before we do that, we need to condense 2 logarithms down to a single. Let's go ahead and try to solve an inequality. Now, with an inequality, we always like to use 0 as the number we see on the left. So this is going to be x minus 2 over x plus 3 minus 2 less than 0. Now we have multiple terms on the left-hand side, so we want to condense that. And I'm just creating a common denominator here. And then as a next step, I will simplify that numerator. So I have x minus 2x, so I'm going to have negative x here. And then -2 minus 6, so negative x minus 8 over x plus 3 is less than 0. And as a final step here, I'm just going to move so we have a little bit of room. I'm going to factor that negative just to make things a little bit easier to deal with. So now this is a rational function, so when I solve this, I need to take into account all possibilities, all reasons why my graph might have a new interval. Well, the things I need to focus on are x-intercepts and vertical asymptotes. In this case, I have an x-intercept at -8. So my first interval that I'm going to test is -∞, to -8. My next interval I'm going to test goes from -8 to -2. And my final interval is going to go, -3. And my final interval is going to start at -3 and end at infinity. And now what I'm looking for here is really, is this interval part of my solution set? So what I'm going to do is I'm going to test some value I like using nice, easy numbers to work with. When I test negative 10, I'm going to have a negative value times a negative value in my numerator and a negative value in my denominator. Those three negatives lead to a negative, so that is part of my answer. If I were to plug in, say, negative 5 on the interval between the asymptotes and the intercepts, I would get a negative times a positive in the numerator and a negative in the denominator, and a negative divided by a negative is positive. We're looking for negative values. And then finally, I can use whatever I like. Let's use 0 here. I'm going to get negative times a positive over a positive. And again, that's what we're looking for. One negative in the numerator will make a negative answer. So our solution set for this inequality will include negative infinity to negative 8 in union with negative 3 to positive infinity. This video is getting a little bit long, so I'm going to keep it moving here. We have 2 more problems we want to look at. First, we're going to find a difference quotient. The hard part here is remembering our formula. And if we know what we're looking for here, this formula should make more sense. The difference quotient allows us to find the slope between 2 points on a specific curve, even if I don't know what those points are. So you can see your formula right in front of you. So I'm going to go ahead and build this out. This is going to be on the numerator, x plus h squared plus 3 times x plus h plus 2 minus the quantity x squared plus 3x plus 2, all divided by h. Now we need to simplify quite a bit of what we have up on the top of our fraction. So we're going to have x squared plus 2xh plus h squared plus 3x plus 3h plus 2 minus x squared minus 3x minus 2. So we have a big long string of numbers there in the numerator, and I'm going to do my best to cancel anything in common. So the 3x and negative 3x, the 2 and negative 2. And then once I finish this up, what you'll notice is all the terms that are remaining have an h in them. So I'm going to divide that h out just as a simplification here, and we'll get 2x plus h plus 3 as our difference quotient. So again, what is this difference quotient? It allows us to find the slope between 2 points if all I know is x, the first point, and h, the distance to our second point. So if I know those values, x and h, I can find the slope between those 2 points at any time. Last thing we're going to do is related to solving, but this is going to be defined in inverse. The way we find an inverse is we flip our variables and then solve for y. So you can see here our inverse is going to be plus or minus the square root of x minus 10. Now just a quick note on this. This is a function whose inverse looks like this. You may notice that it would fail the vertical line test. So what we will do occasionally is we will see problems where they will limit the domain. And as a result, our inverse will also be a little bit easier to work with. And that'll wrap up our second video. Thanks for your time, everyone.